Welcome to our tutorial for our new buoyancy system in Waterline PRO 6.4. Now, if you've been using our plugin so far, you may notice that we have currently a physically based buoyancy system that uses rigid body physics. So right now, if we were to quickly just set this up like so and hit simulate, you can see our boat is moving with the waves as expected, although because this is using rigid body physics, things like mass and acceleration and frame rate do have an impact on how objects like these cubes and the boat move. Now, this isn't too much trouble for single player games, but for multiplayer games or games with massive ships or tankers, this can be a bit of a headache because it's a bit difficult to manage. So this is why we added a new buoyancy system. So let's just simulate a little bit of ocean here. And all of these actors will be coming in the asset pack over here under vessel presets, non-physical vessels. And since in this map we're using the Gen 3 ocean, we're gonna go here and simply drag in one of our boats. Now they have these little cubes on the side just to differentiate them. You can hide those, but those are basically the sampling points. And right now, if we were to hit simulate, you'll see that this boat moves along with the ocean a bit differently than the other one, but still does so in a plausible manner. We can move it and it will follow the ocean. So, how do we create this? Well, let's make one from scratch. We're gonna create a blueprint actor and we're gonna call it BP demo boat. Let's open this right up. And for starters, we're gonna basically need a static mesh. Perfect. And for our static mesh, let's make it the default scene root and search for our boat model. Perfect. And now that we have our boat model, we're going to be needing to set up our floats really quickly. So this can be pretty much any component, but just to make things a bit more visible and easy to understand, we're just going to use a cube. Very good, and we're gonna, let's just make it a bit smaller, 0.1. Perfect. So when setting up our cubes, we're going to be having sample checks in the z-axis for what will be roll and y-axis for tilt. So let's set this up right now. So our location for this one is going to be on the x-axis. Let's go with 70 like so, and we're gonna call it x positive plus. We're going to let's just change its color to so, and we're gonna create another one of it, and we're gonna move it to the negative offset. We want to make sure that they're equally spaced apart, and to keep track of it, let's call it x negative. Next up, you guessed it, we're going to create something similar, and just to differentiate it a bit better, we're going to make it green, and we're going to call it y positive, and we're going to move it to the front of the boat like so. Let's see, 160 is pretty good. We're going to duplicate it and call it, whoops, y negative, and move it to the back. This is pretty good. Let's call it minus 200. Perfect. So this is pretty much all that we need. We can actually turn off collision for these objects. We don't really need it. Just to mess up additional things. But overall, that's pretty much what we need. We can hide these, but just for the sakes of demonstration, we're gonna keep them here. Alternatively, we can also adjust their height a bit, depending on how we want our object to float. But for now, let's move it a bit down and start building up our logic. Now, under the construction script, we're gonna go and use some of our new dedicated ocean actor functions, and these are going to be, if we just type actually Gen 3, and we have a bunch of these, and we're gonna grab, let's get our ocean references Gen 3 over here. And this will pretty much set up some variables here for us, and we wanna get we're going to promote this to a variable, call it our ocean actor, and our ocean, whoops, not watch, but promote to variable, and ocean buoyancy solver like so. Let's make sure they're connected, and we are good. Next up, let's start building up some logic in our event graph. So sometimes it may be worth to copy this over to event begin play if you don't have it set up on construction script, but we're not going to do this right now. So for starters, what we want to do is have a bit of a Gen 3 ocean shore factor. And basically what this does is it's going to tell us whether or not this object is near the shore and if the shore factor should be applied. We're going to promote this to a variable. We're doing good. And of course we need to populate this with a self reference and our Gen 3 ocean actor that we just created as a variable in the construction script over here. Okay, we can compile and move on. So next up, what we need is right click and let's search for Gen 3, and we're going to do an ocean sample Gen 3 like so. And we're going to populate it, and again, we're going to have to input our ocean actor over here and our buoyancy solver over here. Now for float, we're going to need to keep a track of these a little bit during the initial setup, but basically we want which one of these points here are we going to be sampling, and we want to start with the X positive over here and connect it, and now we're just going to basically copy and paste this whole thing, and we'll be getting our X negative value over here. Let's connect so they're both executing. And what we're going to do next is grab these 2 points and calculate the angle between them. So if we go to Gen 3, ocean surface angle is what we want. We're going to connect the top one to the float positive because it is the positive, and the negative one to the negative value. Angle multiply is a bit of a parameter that you can customize. Ideally, you might want to set it to 1, but we're just going to promote this to a variable. And with the x-axis, we're actually calculating, let's comment this, the roll. And our angle multiply is going to be roll factor. Let's do a quick compile. We would like to expose this value so we could tweak it as needed. And we're just going to set this to 1. Okay, great. So now we're going to do the same thing for the pitch. So we can just copy this whole thing, make sure it is executing, and we're going to replace these two with our y values. So y positive, y negative, and something that we're doing is now that it's y values, we're calculating the pitch. And for the ocean surface angle, we basically need to tell it, yep, we're calculating the pitch this time. So this is all good. And of course, roll factor should be done as something different. And let's go with pitch factor. Promote this to a variable that is exposed. Let's do a quick compile and set it to 1. So it's not actually canceling out our pitch and rolls. So next up, what we would like to do is, well, it's actually quite simple. We can grab all of these, and we're going to be using a set actor location and rotation. And this is pretty much what's going to be driving the motion of our boat. So what we need to do is supply it with a new location and a new rotation. So let's do all of this. Oh, one thing that we like to do is enable the sweep, so our object will move with respect to collisions around it. This is a bit optional depending on what you're after, but generally we prefer to keep it on. So let's start with figuring out the position, the ocean surface height. So let's go with Gen 3 again, and what we want is the ocean surface height over here, and it's going to give us this big function over here. So let's start populating it. First of all, we need a reference to self. We need the ocean actor Gen 3. We're going to need the ocean buoyancy solver. Average float height. Now, this is the height of all of these guys over here, and, well, basically they're average. So what we need to do is simply add them up. And since there's going to be 4 of them, we're going to be doing this. And we want the height, so just the Z value. We're going to right-click, split structure pin, and here is our Z value. Now, we have a few parameters over here that we can adjust, so we're just gonna grab our drift, promote it to a variable. Let's see, ideally we wanna have a drift of, default value of 50, although we're going to expose this just in case we wanna change this on a per actor basis. The offset is a quick and easy way of adjusting how far above or below the water something should float. We're going to expose this and set it to something like 20 for now. Water linear dampening. We're going to be explaining this a bit more, but let's just expose it over here and set it to 10. Shore factor is our shore factor from here. So we will just reference it like so. And for delta time, we want to get world delta seconds. Now, since this is the Gen 3 version of the ocean, this doesn't really have any multiplayer capabilities. But if you're using a Gen 4 actor or building something towards that, we will have a separate tutorial along it. But for a multiplayer environment, you want to set this to either 0 or 0.1. Do not use this node as it will cause some issues. But right now we're focusing on single player, so we're just going to go ahead and populate it like so. And yeah, pretty much this will figure out the position of our actor in regards to the ocean. Now, what we need to do is figure out the new rotation. And what we're going to do is look for, Gen 3. And what we need is ocean surface orientation. Perfect. And we're going to get the self-reference. And ocean angle roll. Pretty much what we need is, well, our roll over here. And connect our pitch. Now, angular dampening is something that we're going to go over a little later as well, but this is a variable that we can adjust as needed. We're going to go with a value of 5. Shore factor is shore factor, and we're just going to copy this delta time over here. Now, the next step is a little bit optional, but we also have Gen 3 ocean angular drift. And what this will do is basically rotate the boat in the direction of a wind or a specified angles. Just so, for example, it's always facing parallel or perpendicular to the waves. This is not really something, how should we say, physically set, although none of these nodes are, that's the whole point. This is more of something like a custom modification that you can put on top of everything else. So let's populate it with our references again. I'm gonna grab our ocean actor, and for object orientation, we're gonna plug our previous node over here. Angular drift dampening, this is going to be a variable over here. Right now we're gonna set this to 0. Shore factor is shore factor. Sample ocean wind direction. We can promote this to a variable as well. Let's just make sure that these are all exposed. Angular drift angle. This is something to use when we're not using the shore. So it's something that we can hard code and reference and drive independently quite easily. And for delta time, we're going to populate it like so. Now, I want to have an easy way of enabling or disabling this node. So I'm going to go with select over here. I'm going to go with option 2 to use this, option 1 here. And I'm going to create a new variable, use angular drift. I'm going to expose this and connect it like so. And now, with all this done, we can set up our new rotation. And we are pretty much good to go. Now, we're going to do some more modifications to this. So, for example, right now we're using event tick. This is not ideal for this kind of operation. You can use an event timer. And we're going to show you a more complete version of this overall blueprint. But you could see how these are like little building blocks now that you can mix and match and create more complex structures. So right now, whoops, let's grab our blueprint demo boat over here. Maybe make it a bit bigger and simulate. And now, quite interesting, you could see that our boat is floating quite low. So this is an interesting little side effect. So one thing that we could do is, let's see if we just missed something. Yes, we did. So when we said the average here, we didn't actually average it. So we actually need to divide this by 4 over here, connect it, and we are good. Now, this particular boat will show the ocean on the inside, and that's because we have a sort of lid for it. So we can actually go ahead and add this in viewport. Let's create another static mesh, call it lid, and search for boat polymesh extract. Now this will close it, but we actually have a water hole material to it that we can apply, compile, and right now if we go into play, same as our other boat, the ocean inside is hidden. So let's just have an overall look at how this more complete version of the blueprint is constructed. So we kind of have it over here to the side, and we have a couple of extra nodes. We're just using this here, may not be needed. And again, we're using this on a per event tick, is to have a timer by function name, have a custom event called run. Let's go with run over here. We can set this to loop, set a custom frame rate, so something like, whoops, 30. We want to make sure it's running at once per frame just to avoid any issues. We're going to remove this, and upon begin play, we're going to go run event. And now if we were to drop it, our boat will be running at 30 frames per second. Now you could see its motion is a little bit more jaggedy now. We could really drive this at like 10 frames per second. And yeah, now you could basically see that the function is running, and this is a more efficient way of doing things than per tick. Right now, for demonstration purposes and just ease of use, we kind of have it set up like so. What else do we have though? We have a couple of additional nodes here, and one is called water ambient motion, and this will kind of like jiggle your boat around randomly. This is pretty much useful if you're going to go with something like a lake or a very still ocean where the ocean itself may not have enough force or displacement to drive motion of your boat. And overall, we have just a small check over here that does a 1 second delay before running this set actor location and rotation. And that is just to give enough time for the ocean actor that is being referenced by this actor to fully initialize and start running, because otherwise we might get some errors. So after we've sampled our ocean for the fourth time, we're going to do this only once. We're going to add a small delay of 1 second over here, and we're going to set this to go. Prior to this, the start function is set to false, so the second branch over here will not trigger. Now, again, let's go to our Gen 4 version, and you could see that it's pretty much the same, except the nodes over here use the Gen 4 version. Some nodes, like the surface angle, or ones that don't have explicitly a Gen 4 name, can be used the Gen 3 versions. They're identical, and pretty much everything is same as before. Now we do have a more advanced version, and this is aimed at multiplayer projects called the Gen 4 Baked. And we're going to be going this into more detail later on. But this basically has some additional logic, especially in the way that the ocean is sampled, that we have the baked ocean rotation, speed, and direction, as well as some logic over here that figures out which ocean cascade it should be using for all of this. This one is referencing the ocean buoyancy solver of the ocean actor itself, so it doesn't need all of this logic, whereas this one is actually using a separate buoyancy solver that we will cover again in a separate video. And it uses, as you could see, the delta time over here. Doesn't use that other node, but we're using the 0.001. And yeah, this is pretty much it. We have some debug functions here that you may want to use. We have some functions over here designed on multicasting, but we will cover these in a later video. For now, this is how you could quickly use this in a simple kind of way. Oh, and one more thing, in case you're using a really large mesh, like say a tanker, and ideally you'd want to have a few more samples, let's grab our demo boat. And an easy way to do this would be just to, select our both X's, move them forward a bit, and we could actually duplicate this to X plus 1 and X minus 2. So now that we have both, we could move them a bit further back. X minus. One of these should be positive. So let's name this. This can be a bit of a tricky situation when it comes to naming all of these. May have messed these up a bit more than I should. C. There we go, X plus 1 and X minus 1 with the quick Control D. Okay, perfect. So how would we integrate these new floats into the overall event graph? Well, we're going to grab the roles function over here. We're going to be replacing this +1 and -1 over here. So now what we really want to do is add the reference over here. So this one is the simplest one. Just add 2 more. And because it's average, we're not going to be dividing by 4, but by 6. And for this one, well, we're also going to be doing pretty much this, the average. So we're going to be adding these two. Because this is another roll calculation, we don't want to involve it with the pitch. And we're going to be dividing, by 2. Let's make sure that these two are getting executed as well, like so. And we're pretty much good to go. Our demo boat is not present in the level at the moment. And technically, this shouldn't make too much of a difference in the overall motion of this boat. Technically, it will be a bit more accurate on paper, but you can see that there isn't too much of a difference going on right now. So, since we're working with our actor over here, just make it a bit bigger. Let's go over some of these parameters. Now, roll factor and pitch factor are things we could use to stabilize our boat. For example, if we set a roll factor to 0, you could see that our boat is basically rocking back and forth, but not sideways. So this is good, this isn't happening. So this is what this does. Pitch factor is, well, pretty much the same thing, but for the other axis. So you could see now our boat is moving sideways a lot, but not backwards and forth. Now, if we're going for realism, generally you may want to lower the pitch factor a bit, although because these two are farther apart, it'll be generally more stable. Next, for drift, it is how much our boat is, well, drifting with the ocean. Now you could see some, if I were to go like so, it's not liking it, but our boat is moving sideways a little bit. So for example, if we set our drift to Let's see, 200. This might make it explode. But you could see a lot more motion sideways coming from our boat. Let's go with something like 1,000. There you go. You could see much more extreme movements. They're quite sharp. And yeah, it's overall escaping a little bit. The offset, if we set it to 100, you'll see that our boat is now floating above the ocean. If we go to 0, it'll sink farther in. Now again, this can be kind of adjusted with the position of the floats around the boat, but this is just a quick sort of on a per actor control you can have over it. Next up, water linear dampening and angular dampening are quite interesting because while they work like their counterparts with the rigid body system with physics, these values work almost up in an opposite way. For example, setting them to 0 will basically turn them off, which is also kind of the same thing as setting them to an extremely high number. And basically this means how quickly will the boat move between different sampled positions. So for example, if we set this to, well, let's just turn it off basically and see what happens for position. We have much more bouncy, jackety motion, whereas we set it to, well, 10,000, we're pretty much having the same result. But if we set it to 0.1, or actually 0.01, you could see that our boat is not moving at all, or moving rather really slowly. This might have been rather an extreme value. So if we go to 0.1, yeah, you could see that with the boat's movement, so backwards and forwards and sideways, there's a lot more weight to it, although our angular dampening is still the same, so it's actually rotating much the same way. Let's see if we lower this. And now we could see that our boat's overall motion has much more weight to it. It feels like it's a larger ship or even a tanker of some sort. So these two values allow you to do that. Now, angular drift dampening is something that we have not currently enabled, so let's just enable that. But the dampening will basically mean how quickly it will rotate to, let's see, use angular drifts. Oh, we don't want the ocean direction, we want to set this ourselves. Now if we were to hit play, you could see that the boat if we were to rotate it, it is slowly spinning to face 90 degrees. So for example, if our wind was coming from that direction, we'd want to set this. Although we can, instead of manually setting this value here, we can just sample the ocean wind direction, which at the moment, I guess is, well, this. So yeah, overall, these are some of the parameters we have here. Our built-in boat has a few extra ones for the ambient motion, enable, disable speed, and so on and so forth. Whoops, shore factor should not be exposed ideally. We'll correct this in the full release. But overall, this is the new system, and what's great about it is that it's not influenced by physics of any sort. So right now, if we were to actually spawn this, we can climb on top of it quite easily without having too much influence on overall mass of the entire structure. Whereas with this, sure enough, it's good enough to support us, but if we start piling on cargo and crates and these little floating objects over here, its mass will change, it'll start sinking, and it'll be a bit more complex. This is more responsive to players, so you can rotate it and bump into these, and they're a lot more interactable than this. This one's a position you can't really influence as a player, so this is ideal for big ships, vehicles, and so on and so forth. So yeah, just note that this is still a bit of early testing of this new system, and we're kind of looking for feedback, so feel free to let us know what you think about it and offer any suggestions or helpful tips that we may have missed. So until next time, go make awesome things.